a successful orbital launch. Those 4 payloads are part of NASA's ELana program, the Educational Launch of Nanosatellites program. The mission is designated ELana 41, also designated the VCLS Demo 2 mission for the Venture Class Launch Services program, which aims to provide dedicated launch services for small satellites like these CubeSats. 3 of the CubeSats are
안녕하세요. 자,
provided by different
아스트라,
universities. The
아스트라의
University of Alabama
엘레나
Tuscaloosa,
40일 발사
New Mexico
생중계를
State
같이
University,
보여드리고,
as well as
그 제가
California
아까
Berkeley,
우리 그
and then the 4th payload is
중단되었던
direct from the NASA Johnson
우리
Space Center. All 3
아이언스페이스의
ELaSat
원앱 지금
CubeSats on
배치
board,
광경도 같이 보여드리도록
and they're also the
하겠습니다.
payloads on board Astra's first mission to deploy payloads into orbit, like I said. And as ELana mentioned, no
그래서
weather or
여기 이
technical
발사는
issues right now. The
잠시만요.
countdown is proceeding. Over the course of the
이건
broadcast, we'll
아니고.
also keep you updated how that countdown is proceeding with any updates as needed. This mission does build off of the first successful orbital launch from Astra, which was the LV-000 satellite out of Kodiak Island, Alaska. And let's take a look at a quick recap, which shows how Astra got to today.
10, 9, 8, 7, 6.
일단 저 지금 모습은 작년 11월에 자, 아스트라가 첫 궤도 비행을 성공한 발사가 되겠습니다. 그래서 그걸 보여주고 있고요. 네, 아트로스는 굉장히 그 역사적인 발사였다고 이야기를 할 수 있고요. 그래서 제가 그 원앱 발사도 같이 원앱 지금 별자리 표시하는 과정도 같이 보여드리도록 할게요. 네, 지금 표들이 지금 분리 과정도 보여주고 있죠.
Ether confirms good startup. Seco.
And Astra's LV-007 has successfully reached orbit. There is a new orbital rocket. And we are now going to welcome a special guest to today's live coverage. Hemant Charazia is a Vice President of Product Management at Astra. Hemant, thank you so much for joining the live broadcast today.
Thanks so much, Thomas. It's great to be here.
보이지
So I want to talk
않았는데요.
to you a little bit about what you
프로덕트
do at Astra
매니지먼트.
and how you contribute to the team. So your role is Vice President of Product Management at Astra. What are your
이
responsibilities?
발사는 그
Yeah,
나사
great
스페이스
question.
플라이트
I'm part of the product
독점
management
중재이기
team
때문에
at
저도 어쩔 수 없이
Astra,
여기서
and
가질 수밖에
of course,
없습니다.
one of the stars of our team. Overall, the product management team is really all about answering the question of what is the right thing for Astra to build next. And that's based on understanding what the market is deeply,
짧게
understanding what our
보여줄게요.
customers
일단은
need, and understanding what we can build. You can imagine that that's a very cross-functional activity, but fundamentally it's about charting that course forward and creating a few different things. One would be our North Star vision for the products that we're building and the roadmap of releases that in step-by-step get us there towards that North Star vision.
You mentioned this being sort of a cross, a cross kind of capability where you have to work with other people. Do you work closely with the engineering and operations teams when you're developing these new products?
Yeah, absolutely. Engineering and operations are two very, very critical elements of the company to engage with in answering these questions, but also so many others. I think of program management, think of production, sales, mission management, finance, regulatory, spaceports. So many. There's a long list of internal and external stakeholders that every one of them has an important piece of the puzzle in understanding what is the right thing to build next that makes the most progress towards our vision for Astra.
Well, when aiming to grow your teams in order to pursue that Astra's kind of overall overarching goal as a company, what kind of skill sets and backgrounds are you looking for to join the product management team to achieve those goals?
Yeah, great question. And we're actually hiring very aggressively right now, looking to dramatically grow the product management team this year and as we expand the scope of what we're building at Astra.
그래서 자, 현지 시간, 즉 동부 시간으로 오후 3시, 한국 시간으로 오전 5시에 발사가 됩니다.
We're really looking for people who are obsessed with understanding who the customers are and what their problems are and how we can help solve those problems. And then bring those insights to the rest of the team as part of our product development process. Second thing I would highlight is it's important to have a combination of technical fluency and business thinking. So product managers in this process, as you can tell, are really a bridge between the business side of Astra and the technical side of Astra. And so it's important to be able to work and speak equally well with both. Third one is ability to learn fast. You can see on the pad today, our launch system, our most celebrated product at Astra, is really the first of its kind. There are no other container shippable rockets, and what we're doing is a first in so many different ways. So everybody in the product team really has to be able to learn fast about new technologies, new markets, new types of businesses. And then the last thing I would say is ability to bring people together.
근데 솔직히
ability to
말해서
convene, to
이
influence,
나서
to
스페이스
really
플라이트도
align a broad
말
cross-functional
그대로
team
유튜브 채널이기
around a
때문에
vision for the product, a thing
요건
we're
제가
trying to do in the
잘릴지도
world,
몰라요.
and then
그거
to
감안하고
ship
보세요,
that,
그냥.
to work together
보세요.
to bring that into reality. And so these four key skills are intrinsics we look for, and we have great people in our team right now. In terms of backgrounds, I would say that product managers in aerospace are a bit of a rare breed. It's not really a traditional role. So there isn't any cookie cutter formula for background. Certainly, people who have had product management experience at other companies that build mixed hardware and software products, they will have had an opportunity to build many of these intrinsic skills we're talking about. So that's a great background. But also, it doesn't have to be that. And also, it doesn't have to be any particular industry. At Astra today, we already have a very diverse range of backgrounds at Astra. People have come from automotive, from big tech, from aerospace, from all sorts of different industries, and we hugely value that. It's really an important part of the magic at Astra about building something that's fundamentally different as a new future for the space industry.
자, 그리고 지금
And so that team, which comes from all of those
지금
different diverse backgrounds
아리안
and
스페이스 같은
experiences,
경우는
is all
안
coming into
나오네요.
Astra to achieve Astra's or aim towards Astra's long-term goal of improving life on Earth and from space.
이게 좀 쉽지
How
않죠.
does today's mission, the LV0008 mission, and your work in the product management team work towards achieving that goal?
지금
Great question.
아리안 스페이스
And,
같은
I
경우는
love
지금
this
두 개의 위성이 분리가
question.
됐다.
It can never be asked
네,
too
지금
many
뉴스가
times.
지금
I
나왔고요.
think, big picture, a really important step in improving life on Earth from space is to develop the scientific understanding and the scalable technologies that we'll need to build something really useful in space, the next generation of space-based services. That's really what I see as the theme of today's mission in a few different ways. And the 4 satellites that we're launching today from 3 awesome university teams and NASA's Johnson Space Center. The way I look at it, the 4 satellites we're launching today advance
지금
2
어디
broad
발사 지금
goals. The first one is to
발사
help
지금
scale up
장소는요.
our use of space,
그 플로리다에 있는
and the second is to do
케이프
that more
커네버럴
sustainably.
우주기지예요. 그래서
So on the first
SAS
theme, this scaling up,
스페이스
the
런치
first
센터
one I'll highlight
46에서
is the
지금 발사를 지금
R5S1
준비하고
mission
있습니다.
from NASA Johnson Space Center. They're really demonstrating a faster and cheaper way to build CubeSats, and simultaneously testing out new ways to get better data on how satellites are operating on orbit. This is very useful diagnostic information for scaling things up. The second payload that fits in this sort of theme of scaling up is the CubeSat mission with a Q from the University of California, Berkeley. And they're testing out a new kind of quantum gyroscope. A gyroscope is a critical element of every satellite on orbit that helps the satellite understand where it's pointed and where it is. And making
오늘은 과연
these,
잘 발사가 될 수 있을까요?
this quantum gyroscope is one potential path to smaller, lighter, and cheaper gyroscopes. That's another way to scale things up in space. Overall, these two give us new ways to make cheaper and more scaled satellites. On that second theme, though, on sustainability, I would say that the first one, the BAMA 1 mission from the University of Alabama, Tuscaloosa, will test a new drag sail, which is a bit like, you can think of it like a parachute in space.
이걸 다 뜯어야 되는 거죠. 아, 그거 불가능하고. 이것도 이상해요. 미안해, 이걸 이걸 꺼낸 건 자체가 불가능하니까. 나 이게 높을 줄 못했어. 일단 아, 아니, 피가 장난 아니네. 이 정도 높이 있으면은 대박. 그러니까 좀 힘들어. 높이를 안 보고 왔어. 우와. 아, 그럼 저게 딱 괜찮긴 하지, 지금. 그런데 이거를 뺄 수가 있는 방법이 하나 없으니까. 나 이거만 해야겠다.
Step 105, Tango and AV1 manage polling. Please toggle do both ground and guidance polling mode.
Toggling do both
아,
ground
제가
and guidance
잘못했네요.
polling.
죄송합니다. 제가 착각을 했습니다. 이거 이제 43분 남았는데, 42분 남았는데, 아직 특별한, 아직 그, 상황은 아직 펼쳐지지 않고 있는 것
And Tango,
같습니다.
I'd like you to re-enable pump battery charging by going into machine pump battery 2 manage pump batteries and setting mode 3 reset machine.
Toggling 3 reset machine.
And then mode 1 charge pump batteries.
Toggling 1 charge pump batteries.
네, 아직 특별한 모듈은 아직 하나도 올라오지 않아서, 네, 이제 그냥 그대로 지금 진행이 되고 있다. 이야기를 할 수 있습니다.
So we just listened in on some countdown steps being proceeded. Again, everything on track right now. We're at just under 42 minutes and counting for today's launch. Again, targeted for 3 o'clock p.m. Eastern Time. Like we said, we want to take some questions from chat over the course of today's broadcast. So again, if you've got questions, tag us with @NASA Spaceflight, and we're going to be bringing a couple of those in, and we got a few of them here now. Keith is asking about the last launch that Astra conducted, the LV0007 mission. What was the goal and achieved objectives of that mission, Carolina?
Yes, so the LV0007 launch in November, we saw the video of it just a few minutes ago. If you joined us at the beginning of the broadcast, that was our attempt to reach orbit. We have constantly been working towards that milestone, and LV0007 successfully reached orbit with a test payload on board. And so that test payload on board LV0007 was not deployed. So today's mission, LV0008, represents a few firsts, one of them being that this is the first Astra mission with payloads that we will deploy into space.
예,
As you
지금
just heard,
배지를 보니까 아스트라
a lot
관계자
about
같대요.
these exciting CubeSats and the scientific investigations that they will conduct. And it's also our first launch out of Cape Canaveral. So it's a couple of historic firsts for Astra with today's launch, and we are very excited to see how it goes.
And a related question, Arda is asking if Astra can launch payloads into polar or retrograde orbits, and I believe that ties in directly with the launch site that's being used for any particular mission, right?
Right. So if you have been following us for a while, we have launched our previous rockets out of Kodiak, Alaska, the Pacific Spaceport Complex, Alaska.
참고로 지금 발사되는 곳은
and that location, which is a very high latitude, is great for reaching high
코디악이
inclination
아니고
orbits,
지금
including polar
플로리다인데요.
and SSO. So yes, we can reach polar orbits, and technically those retrograde would be flying launching against the direction of Earth's rotation. So there's nothing really to prevent us from doing that either. But we're focused
일단은 한번
on
계속 지켜보도록
the
하겠습니다.
objectives that our customers want to achieve, and a lot of that is driven by our launch location. So while our Kodiak launch site has been great at helping us reach high inclination orbits, this launch site in Cape Canaveral is really wonderful for reaching mid-inclination orbits, which are particularly important for things like communication and weather observation, where you can get more coverage over the middle portion of the globe.
Another launch site question here from Matt. Could Rocket 3 launch from a boat at sea?
That's a very interesting question. I'll talk a little bit more about our approach to our launch infrastructure. So everything that you see in front of you here can be shipped inside a shipping container. And so no launches at sea at this time, but it does make it very easy for us to set up and deploy a launch site. And even the rocket itself is 43 feet from tip to tail. So that fits inside a 45-foot shipping container, a bit snugly, but it is one of the key differences about Astra, where we can ship everything to the launch site, and really all we need when we get there is a concrete pad, an internet connection, and a fence to help keep the area safe.
And we have another question in chat asking about, again, kind of related to launch sites. A lot of launch site questions, which is good because first launch from Cape Canaveral, it's on topic. Does each vehicle get built slightly differently according to where it's going to end up eventually launch from?
That's a great question. And no, that is one of the things that helps us on our path to scale and really improve life on Earth by improving access to launch. So the rockets are built as identically as possible. We may make small tweaks in between because our objective is always to learn and improve our system. However, those at this point, those have been pretty minor, especially given the success of the LV0007 launch back in November. So we do make the rockets identical. It doesn't matter where they are launching from. They are exactly the same. The only differences may be any changes in our communication systems to ensure compatibility with the specific range, and any special payload adapters that we need for that specific mission. Otherwise, it's the same rocket regardless of where we are launching from.
And looking at the launch site a little more closely here, we have a question that we should have known we were going to have, although this is an interesting interpretation of this question. What are the pylons that look like they'd attract lightning for? Well, you pretty much got halfway there. Actually, on this particular camera view, on the very left-hand side, you can see the bottom part of one of the lightning protection towers, and they are there, like you said, to attract lightning. It helps protect the rocket. And Space Launch Complex 46 has two big prominent lightning towers seen here as well to help protect the rocket. But of course, this pad is actually built for rockets. It's one of the smaller pads at Cape Canaveral, but still built for rockets that were traditionally bigger than Rocket 3. So Rocket 3 is just barely poking up over the trees in this view. Even this pad makes Astra's rocket look small because it's dedicated to those small satellites. Another question here, Paul asks, is what makes Astra different from its competitors? What strengths do they have that other providers maybe don't have?
That is a wonderful question. And Astra, our mission is to improve life on Earth from space, and the way that we're hoping to do that is by developing the most responsive and affordable orbital launch system. So in terms of responsiveness, what we were just talking about with our ground support equipment fitting in shipping containers, being easily able to set up and tear down a launch site in a matter of weeks or days. That's one of our key advantages. And the reason that that's important, as we mentioned, is that a lot of the orbital destinations that you can reach depend on where you can launch from. So being able to be mobile and agile helps us to provide customers with access to the locations they want. The system is also really set up by a very small team of folks on the ground and operated by a small team of mission control and support engineers in our facility, which allows us to be really nimble. And it's also been really helpful during the COVID-19 pandemic, where it's allowed us to remain as safe as possible and minimize our travel. And finally, on the affordability front, we take pride in using low-cost materials and trying to lower the cost of access to space with our vehicle. And I believe that Thomas, you had a tour with our facility with our head of production, and that's been an exciting thing to learn a little bit more about how we go through the steps to make our system as affordable and low cost as possible, including staying away from fancy materials like carbon fiber and composites, and using as much automation as we can across our system.
Yeah, Carolina, you set me up for a shameless plug here. If you have not seen the Rocket Factory tour with Bryson Gentile, who was the head higher up in the production side of things at Astra, who gave us NASA Spaceflight a tour of the Rocket Factory a little while ago. It is on the NASA Spaceflight channel. I highly recommend checking that out because it's a wonderful insight to how Astra is working to lower that cost through different means, because some companies are looking at reusable rockets and things like that as a means of cutting down price, where other companies such as Astra here, you're talking about ramping up production cadence of expendable rockets and simplifying the launch preparations and simplifying the manufacturing, the different materials you choose. Those are the kind of factors you're looking at to reduce launch prices, right?
Yes, exactly. That's right. We take a number of steps in order to make our system as cost effective as we possibly can, and hopefully our customers can take advantage of that and get more payloads to orbit.
And speaking of getting those payloads to orbit, we have a question from Redacted. I don't know if that's their actual name or if I just am not allowed to know the name, but we'll go with it. The question is, what's today's trajectory? Is it flying direct east or somewhere else? I believe we even have a graphic to show where the rocket will be headed, and there it is, right on cue.
Yes, so this is the trajectory that the rocket will follow. We'll be following sort of that middle area. Those blue lines are the NOTMARs, the notices to mariners, the area that boats will keep away from, and then the red area is sort of our safe area that we have cleared with the FAA. So after the rocket clears this trajectory, we'll be flying, starting to swing around towards the south again, flying over Portugal, Spain, the Sahara Desert, Ethiopia. So we'll be hoping for a nominal trajectory as we launch out of Cape Canaveral.
And if you are down here in Florida along the Space Coast or even along the southeastern coast of Georgia and things like that, assuming the weather is clear where you are, it is very clear here at Cape Canaveral. Highly recommend taking a look at this launch because the weather does appear to be pretty favorable for launch viewing. It is a different rocket than the ones that normally come out of here at Cape Canaveral, so it might look a little bit different, but rocket engines are pretty bright, and hopefully you'll be able to catch a view. If you're local to Cape Canaveral, highly recommend this spot here, NSF Stephen Marr out there in the field near Jetty Park, and that is a really great viewing location, the best one for Complex 46, because that launch complex is actually on the southern tip of Cape Canaveral, pretty close to the Port Canaveral area. So highly recommend heading out here. 31 minutes from now, this launch will hopefully be taking place, and we'll put on a cool show for the Space Coast here in Florida. If you are not local here to the Space Coast, we are, of course, thank you for tuning into the webcast. Happy to provide you with the views of the launch of this way. And we have a question from Sean who asks, or excuse me, I'm reading the wrong thing. Different question from K2K81. I don't know what that means, but thank you for your question. Are there any cameras on board the rocket? And if Michael gets that cue, he's going to show one of those cameras. There we go. Carolina, what are we looking at on these views?
Sure. So you are looking at the upper stage of LV0008. So that the sort of top right-hand side of your screen, that is the fairing, and we will hopefully see very shortly after main engine cutoff, we will have stage separation and fairing separation, and those fairings will pop open and we'll have a beautiful view of Earth as the upper stage ignites to complete the final leg of the mission. And then this is a view looking upwards at our payloads. So we'll be tracking them as they deploy after SECO, or second engine cutoff.
Love seeing those onboard views. We're hoping to keep those throughout the course of the broadcast and show those as much as we can. We've also got these ground cameras, of course, and with perfect visibility, hopefully we'll get some good views from them as well. I do have a question from Planetary Space, which is talking about the most recent abort and scrub. If you tuned in earlier, this is not the first launch attempt, like we said. This is the third attempt for this particular mission. And last time there was that scrub due to that telemetry issue that the teams had to stand down to resolve prior to coming back today. But we saw that abort happen right at engine ignition. So the question is, what do the teams have to kind of work through when you light a rocket engine and then scrub? Could the engine be damaged from an abort like that, or other systems that have to be inspected and things?
Sure. So first, to speak a little bit about the abort that happened on Monday, our team conducted a data review after our engines lit, and we learned that the abort was due to the rocket detecting latency in our internal telemetry communication, and it was a bit longer than we typically experience. We determined that it was unlikely to have impacted flight, but felt that it needed further review. And after this review, the team was able to identify the probable cause and potential effects and run some simulations to determine that an impact to flight was unlikely, and also test some adjustments to improve the latency of the system in preparation for our launch attempt today. So we believe we have solved that issue. And now, more directly to the question, our system is actually designed for multiple ignition events. So we complete a static fire of the vehicle. It's our last major test of the full system. Essentially, we run through our entire countdown procedure, load propellants, light the engines, and run them for a few seconds, and essentially do everything except actually release the rocket. So we do design the system to be able to complete multiple ignition attempts, multiple launch attempts without damage or issue.
Excellent. We're actually hearing that teams are getting into final software config loads now, so let's go back in and listen to the countdown net as those steps are completed at 27 minutes and counting.
Victor 1-5 on engine Alpha. Good load.
Engine Bravo 175, Victor 15.
Loading config 175, Victor 15 on engine Bravo. Good load.
Engine Charlie 176, Victor 15.
Loading config 176, Victor 15 on engine Charlie. Good load.
Engine Delta 177, Victor 15.
Loading config 177, Victor 15, engine Delta. Good load.
Engine Echo 178, Victor 17.
Loading config 178, Victor 17 on engine Echo. Good load.
Ether, please provide an updated late load
지금
config
보니까
if you
날씨가
have one.
굉장히 좋아요. 한 90% 적합하다 지금 나와 있어서 굉장히
Loading config
발사하기에는 정말 좋은 날씨였습니다.
Good load.
그래서 지금 4개의 큐브셋을 발사하는 발사가 되겠습니다.
Yes. 5 Victor 148.
Loading config 5 Victor 148 on guidance. Good load.
Tango in VB1, turn on off PDBs. Please run a GNC setup. GNC, call out when complete.
Toggling GNC setup.
So as you just heard, teams are working on those final software loads, and those are going well. T-minus 25 minutes and counting, all on track so far. So we'll keep some questions coming, and the liftoff is still targeted for the opening of the window at 3 o'clock p.m. Eastern. This question from Sean for Carolina: how big is the launch window today, should any issues have to come up?
Right, that's a great question. We have a 1-hour launch window today. So our launch window extends from 12 p.m. Pacific 1 to 1 p.m. Pacific. I am blanking on my UTC math at the moment, but we do have a 60-minute launch window. If we encounter an abort or an issue, our recycle time is typically around 15 minutes once that issue is resolved, so there is a possibility that we would be able to try again in the event of an abort. But again, everything looks nominal at the moment, so we are not anticipating any issues at this time.
If I use the time you took to answer that question to do some math in my head, I think that translates to 2000 UTC to 2100 UTC for those of us watching, or those of you watching from across the globe. Thanks for tuning in, and that is our launch window for today. I have another question here from Santosh, who asks, what engine does the rocket use? And I'll just expand that really quick because I believe we have a cool view of all the different components of this rocket. Carolina, want to run us through what makes up a Rocket 3 from Astra?
Sure. So on the left side of your screen, you can see the expanded view of our rocket. We'll start from the left. That is the engine bay. You can see 3 out of our 5 first stage engines, the Delphin engines. They are electric pump-fed engines, each producing a thrust of 6,500
지금
pounds.
아스트라
For a
지금
total of 32,500
로켓 3
pounds of thrust on the
3.3이에요.
first stage.
3.3
The next large section is the first stage
V007
tanks.
8인데요. 예,
And
구조에
those are
대해서
filled
이야기를 하고
with
있습니다.
LOX and kerosene, liquid oxygen and kerosene, which are our propellants for both stages of the vehicle. The next section is our inner stage, which houses the large portion of the upper stage and our avionics system. Then further right, we have those 2 spherical tanks and the smaller engine with the long nozzle extension. That is our upper stage. Again, the upper stage is filled with LOX and kerosene, just like the first stage, and we have 1 pressure-fed ether engine, which produces 740 pounds of thrust. And then finally, you see those 2 split halves of the fairing. And on top, we have of the upper stage, you can see an example of a CubeSat payload. Again, today it represents Astra's first mission deploying customer payloads into orbit, so we will be keeping an eye for that fairing separation and the payload deployment at the end.
그리고 지금 아리아스페이스 같은 경우는 거의 1시간 거의 한 30분 이상 지금 계속 날고 있고요. 어차피 한국 시간으로 예. 한국 시간이 아니라 지금 UTC 국제협정실 해가지고 거의 9시까지는 계속적으로 9시 한 40분까지는 계속적으로 배치를 하니까 시간이 굉장히 많이 걸립니다. 그래서 아스발사가 만일에 끝나게 되면은 계속적으로 원의 그 배치 과정을 한번 보여주도록 하겠습니다. 일단은 지금까지 순조롭게 돼가고 있는 것 같아요. 그래서 지금 21분 남았고요. 다른 발사 같은 경우는 뭐 21분 정도야 뭐 그렇게 큰 문제 인생이 안 되는데, 아스트라 같은 경우는 이제 발사를 3번째 지금 중단한 경우가 중단했기 때문에 오늘 과연 발사가 될지는 계속 지켜봐야 될 거라고 생각이 듭니다. 워낙에 이제 발사 실패냐 성공이냐 해가지고 원앱이 지금 또 뉴스가 나왔는데 아직도 멀었어요. 이렇게 아까 11분 기준으로 해가지고 2개 위성 분리됐고 32개 남아있다. 계속 업데이트를 할 겁니다. 그래가지고 이게 좀 오래됐군요.
Per step 132 GNC at this time, can you confirm that wind profiles still look acceptable for launch today?
Confirmed.
This takes us to final igniter checks. Per step 133 Tango, on the buttons interface, please toggle spark for 30 seconds. Upon completion, Delphin, please provide results of spark test.
그리고 이제 나온 뉴스가 아스타
Toggling
책임자의
spark now.
캐롤리나 그로스맨이 발사 중단이 왜 발사 중단됐냐면은 로켓이 내부 원격 측정 통신의 지연을 감지했기 때문에 발생했다. 그래서 일반적 경험보다 더 길었다고 말하고요. 그래서 그게 이제 빙행에 큰 영향을 끼치지 않겠지만은 추가 검토가 필요해 있어 결국 예전에 발사가 이제 중단됐다 이야기를 이렇게 나오고 있습니다.
Toggling off spark.
Delphin, please confirm results of spark test.
Delphin confirms good spark.
Copy, thank you.
And you just heard a good spark test, so igniter tests have been completed and the countdown steps are proceeding nominally. We're just about to cross T-minus 19 minutes and counting. Everything going well so far. What you were listening there was the mission control teams in Alameda, California, working through those countdown steps. And ELana, can you walk us through who those team members are and their various responsibilities today?
Sure. So we just have this graphic that has popped up with their names. We'll start from the top left today. So we have Rose Jornalis, who's our flight safety. The flight safety officer is responsible for making sure that we are following our
18분
trajectory.
남았죠.
Then
지금 시간이
Christopher
가까워지고
Rossi is
있습니다.
our GNC guidance, navigation, control, or trajectory. So he's the one who is keeping an eye on our winds and making sure that we are safe to launch and follow our planned path. Claire Gauthier is our vehicle controller, who with the call sign of Tango, and she is the one who is doing the steps to load the software on the vehicle. She's the one who is the operator of our launch system. Chris May is our command and data handling, or CDH, and he's responsible for monitoring and adjusting any of our state machines which operate our system. Hill Hudson is our flight activities officer, or
지금
FAO, and
발사
he's
지금
responsible for
책임자들
the completion of
각각의
our
지금
procedure.
컨트롤러
Chris
아니면
Hoffman
뭐
is
플라이트
our flight director
디렉터
who oversees
이런 식으로
and
지금
directs
보여주고
launch
있죠.
vehicle operations following the countdown manual, and he can call hold, recycle, or abort as required. And then we don't have a tag for Eric Steinberg, known as Steiny, who is our IT
각각의 지금 소개를 하고
network,
있습니다.
point person. You may also hear, as we move through the countdown, the go no go poll, which is coming shortly. We have what we call the engineering backroom of the responsible engineers for each of the different systems on the vehicle and our ground support equipment, who are distributed throughout our factory floor at their desks and monitoring all of their systems there.
In addition to those teams in Alameda, there's another team out in Cape Canaveral, known as the Red Team. And can you tell us a little bit about who's out there for us?
Yes, we have a very small and nimble team known as the Red Team out at Cape Canaveral. They're the ones who set up the launch site, do any work required to configure the vehicle and the ground support equipment for flight. We are very grateful for them and hope they're enjoying the beautiful Florida weather, which is much nicer than it would be in Kodiak this time of year. We have Ryan Hirschfeld, our safety officer. Adam Frisch is our red lead. Robert Freeman, Eric Larson, Sam Hirschap, Benjamin Whelan, Rusty Haller are our red team. And then we also have, in addition to Steiny on our network and IT, we have Thomas Cannon as well. So all of 6 members of the red team we're very grateful for all of the work that they do on the ground at our launch site. They are taking regular COVID-19 tests to protect the health and safety of everyone involved in this mission. And thank you all. Huge shout out to you.
For sure. Right now, 15.5 minutes to go. Again, everything on track so far. At the T-minus 15-minute mark, there will be the entering of terminal count. And that is going to be a big milestone. There'll be some other steps right after that as the teams get into that terminal count, followed by a go, no-go poll just over 10 minutes to go in the countdown. So let's go ahead, listen into the countdown net. We should have a water test incoming and then entering terminal count.
Takes us into Astra terminal count at this time, step 142. Tango, confirm that in AV1 managed power systems, we are in ground power system authority.
Confirm.
Tango in VB1 turn on off PDBs, please run a GNC self-test. GNC call out upon completion.
Running GNC self-test.
Wilco. GNC self-test passed.
Copy. Astra Safety, confirm that FTS is still enabled and nominal in the vehicle.
Safety can confirm.
Tango.
As the teams get into terminal count here, let's take a look at the mission timeline of all the events we'll expect to see after liftoff. Carolina?
Sure. Well, before liftoff, just a few seconds before, the 5 first stage Dolphin
네,
engines
지금
will light,
미션
and then
타임라인
T0,
나오고
if
있어요.
all of the
그래서
checks
지금
pass,
발사가
we will
되면은
have liftoff. The hold down
퀴오버?
mechanisms will
퀴오버가
release the
처음
vehicle,
들어보네요.
and we will be at the beginning of
퀴오버가
our journey.
시작되고
Just a few
자,
seconds in,
1분
we'll begin our
10초에
changeover maneuver,
자, 맥스 큐
and
최대
expect to
도갑
reach
들어가고요.
max Q at around
그리고
1 minute
2분,
and 10
2분
seconds,
50초에
the point
메인
of
엔진
maximum
컷업되고
aerodynamic
2분
stress on the
55초에
vehicle,
페어링 이제
and a
분리됩니다.
significant
그리고
milestone to hit
자,
in first stage flight.
3분에 이제 1단이
Then a few things
분리되고요.
happen in pretty
그리고
quick
이제 상위
succession. At 2
단계가
minutes
이제
and 50 seconds,
이제
we'll
가동이
have main engine
시작되게요.
cutoff or
점화가
MECO,
되기 시작해서
then fairing
자,
separation
2단
and
엔진이
stage
컷오프
separation.
되고
Right
자,
before
8분
the upper stage
40초에
ether engine
페이로드가
ignites
이제
at
4개의
3
큐브
minutes
스시에
and
이제
5 seconds.
배치가 된다,
The
배포가
ether
됩니다.
engine will burn for about 5.5 minutes before second engine cutoff or SECO at 8 minutes and 30 seconds. And then at 8
제가
minutes and 40
오늘
seconds, we will
가정에서는 아마
begin our payload
그
deployment
발사가
of our 4
순조롭게 이루어지는
CubeSats,
걸로
which
질
will
걸로
be
지금 생각이
deployed
듭니다.
within a few seconds of one another, and we are hoping to get a good view of from our onboard cameras. And if we have completed all of those steps, we will have achieved mission success, and we'll consider today a very good day.
All right, let's listen back into the countdown net. We're coming up on that go, no-go poll, which is where Chris Hoffman will poll the rest of the team
네,
for
이제
their readiness for
보도고도 이제
launch.
들어가겠죠.
And hopefully we'll get a go condition to proceed with launch in just over 11 minutes. So let's listen in.
Toggling off chill. Toggling off load first. Toggling off load upper. Deactivating aux4 operate.
Deactivate aux1 OV201 first fill.
Deactivating Aux 1 OV 201 first fill.
Aux 1 OV 401 fill.
자, 그 아리안 스페이스 같은 경우는 지금 일본 1시간 38분 지났습니다. 반사한 지요. 그래서 지금 세 번째 3번 위성이 지금 배치가 됐어요. 회복가 됐어요. 그래서 전체 4개가 지금 분리가 됐, 4개가 분리됐다. 지금 기록이 나왔습니다.
Please deactivate fuel 4 operate.
Deactivating fuel 4 operate.
네, 지금 노고 고 노고 하고 있는데요.
Deactivating fuel 3 supply.
Fuel 1 FV300 upper fill.
Deactivating fuel 1 FV300 upper fill.
Fuel 1 FV200 first fill.
Deactivating
페이로드
fuel
배포는
1
아마 발사 후
FV200 first
8분
fill.
40초 후입니다.
AV1 radios.
굉장히 빠르게 발사가 배치가 됐죠.
Deactivating AV1 radios.
And AV1 rocket support cart.
Deactivating AV1 rocket support cart.
Please confirm zero stop purging is still enabled.
Confirmed.
AV1 manage polling.
Confirmed.
사실상 오늘 발사가 그 아스트라에게는 첫 번째 그 미션이거든요. 거의 지금까지는 이제 시험 발사 그렇기 때문에 오늘 이제 나사의 4개 위성을 잘 발사하느냐 그에 따라서 앞으로 이제 굉장히 평가가 달라질 거라고 생각이 들어요.
Please confirm VB1 first stage power is active.
Confirmed.
VB1 upper stage power.
Confirmed.
VB1 turn on off PDBs.
Confirmed.
Water 1 water system.
Confirmed.
Tango, please activate launch machine.
Activating launch machine.
아직 반응이 없네요. 그래서 지금 컨펌했는데
Yes, launch
확인했는데
activated. Please toggle locks topping.
Toggling on locks topping.
Okay, team, this brings us step 151. Poll for tank pressurization and launch today. After this point, any system issue must be called as a 3-word hold. That is a hold, hold, hold over the net. If there are no concerns for flight, call go. Otherwise, call no go. Red lead.
Red lead is go.
FTS.
FTS is go.
Delphin.
Delphin is go.
Ether.
Ether is go.
Odin.
Odin is go.
Inco.
Inco is go.
Ace.
Ace is go.
Launcher.
Launcher is go.
Orbit.
Orbit is go.
Booster.
Booster is go.
GNC.
GNC is go.
FAO.
FAO is go.
CDH.
CDH is go.
Tango.
Tango is go.
Safety.
Safety is go.
Flight is go. Tango and AV1 manage polling. Please toggle do only ground.
Toggling do only ground polling.
And let me know when you're ready to load flight engine sequences.
Ready.
Delphin, please provide.
Igniter sequence is 703 Victor 3.
Loading sequence 703 Victor 3 on igniter. Good load.
Engine alpha
지금
is
7분 남았어. 8분 남았네요.
Victor 1.
Loading sequence 860 Victor 1 on engine alpha. Good load.
Engine Bravo 861 Victor 1.
Loading sequence 861 Victor 1 on engine Bravo. Good load.
Engine Charlie.
네, 거의 지금 발사는 확정됐습니다. 발사가 이제 될
Loading
걸로
sequence
보입니다.
862 Victor 1 on engine Charlie. Good load.
Engine Delta 863 Victor 1.
Loading sequence 863 Victor 1
참고로
on
지금까지
engine Delta.
아스트라 발사가 13번째 발사거든요. 13번째 발사인데 지금까지 12번은 모두 성공 발사 성공했습니다.
Loading sequence 864 Victor 1 on engine.
요즘에는 어지간해서는 거의 발사 실패가 많이 있지 않아요.
Ether, what can we load for you?
Ether sequence today 842 Victor 3, please.
Loading sequence 842 Victor 3. Rinse and repeat on ether. Good load.
Tango and AV1 manage polling. Set us back into do both ground and guidance polling mode.
Toggling.
All right, you just heard the teams have pulled go for launch and are into the final steps before liftoff. Carolina, this mission is about to lift off. What is the purpose of this mission? One more for people who are just joining us.
If you are just joining us, Astra is looking to deploy 4 CubeSats on this mission. Bama 1 from the University of Alabama, Tuscaloosa, demonstrating a drag sail module that will rapidly orbit the satellite. Inca, ionospheric neutron content analyzer from New Mexico State University, Las Cruces.
네, 최종 고노고 투표가 진행중 완료됐습니다. 그래서 자, 최종 소프트가 사장에 노도 된다고 지금 나와 있어요.
CubeSat from University of California, Berkeley, a technology demonstration to test and characterize the effect of space condition on quantum gyroscopes using nitrogen vacancy centers in Diamond, and R5S1 from NASA's Johnson Space Center, Houston, demonstrating a fast and cost-effective way to build successful CubeSats. These are being launched on the ELana 41 mission, which is selected through NASA's CubeSat launch initiative and provided under a Venture Class Launch Services Demonstration 2 contract, which provides dedicated launch capabilities for smaller launch payloads awarded by NASA's Launch Services Program. So we are very thankful to our partners at NASA for providing us the opportunity to complete this mission for our 4 CubeSat payloads.
Coming up on T-minus 5 minutes and counting, we're going to go ahead and listen back into the
야,
teams as they work
5분,
through the final
5분도 채 안
minutes
남았지
of this
않았죠.
countdown. And we'll be looking forward to a liftoff. Again, liftoff targeted for 3 o'clock p.m. Eastern Time, which is just under 5 minutes from now, and everything on track so far.
네, 5분 남았죠. 네, 발사 지금 순조롭게 지금 진행되고 있고 4분 남았고요. 이 발사는 굉장히 그 빠른 시간에 페이로드가 그 위성이 그 배치가 됩니다. 무려 발사한 지 8분 40초 만에 그 발사 이제 페이로드가 이제 배포가 되니까요. 잘하면은 굉장히 빨리 끝낼 수 있습니다. 성공했다는 그 전제하에 발사 성공했다는 전제하에 한 제가 30분을 넘기지 않을 것이라고 예상을 하고 있습니다. 예. 과연 그 아스트라가 첫 상용 발사를 성공할 수 있을지 지켜보고 볼만한데요.
3 minutes and 30 seconds.
정말 버벅하십니다. 할 말이 없습니다, 제가.
Rock, this is flight on countdown. Please confirm range is recording telemetry at this time.
네, 발사 3분 전이죠.
Control room, if you require RF data in flight, be prepared to switch over your pages.
네, 케이프 커넬에서 발사하는 첫 번째 발사가 되겠습니다.
MIFCO, prepare to issue option when rocket IIP marker passes min-MECO point and is within dispersed trajectories, calling out at event. MIFCO copies.
그리고 지금 아리안 스페이스가 그 3시 9분에 발사했던 그 원의 그 13번째 원의 위성이 지금 발사돼가지고 1시간 지금 40분째 넘어가고 있어요. 그래서 계속적으로 배포가 되고 있다 이야기를 해주시고요. 아마 이 배포 과정도 굉장히 오래 걸립니다. 자, 2분 남았죠. 이제 시간이 진짜 안 남았습니다. 과연 오늘 또 새로운 역사를 또 쓰게 될지 기대를 해보겠습니다. 2분 전이죠.
FTS this time send master enable and watchdog on AFTU. 2 minutes.
전번 발사가 그 완전히 그 카운터를 끝내고 점화까지 해놓은 상태에서 중단을 했기 때문에 또 모르는 겁니다. 네, 과연 성공할 수 있을지.
Copy. Thank you.
그래서 모든 결국엔 끝까지 봐야 되는 상황이죠.
90 seconds.
예, 90초 나왔다는 얘기죠. 발사 성공은 거의 뭐
Ace at this time. Start
굉장히 빠른
PST
시간 안에 알
recordings
수
and
있을 겁니다.
downrange ground station recordings.
Good work.
일단은 지금까지 모든 상황은 매우 좋습니다.
60 seconds. Vehicles on internal power.
네, 지금 이제 60초가 채 남지 않았죠.
PSD recordings enabled.
45. First stage coming up to liftoff pressures. Tanks are pressurized at this time. 30 seconds.
오늘은 이제 발사가 성공이 되면 진짜 아스트라트론 아마 상용 발사가 되니까요.
20.
네, 20초 남았습니다.
15. 10. 9.
9.
8.
야, 드디어
seven,
올라갈까요?
5. 4. 3. 2.
와, 발사됐습니다. 올라가네요. 네, 올라가고 있습니다. 발사 성공했네요. 네, 발사
LV0008 has launched and is on its way to space. You can
네,
follow the
올라가고
flight
있고요.
on the left side of your
지금
screen,
초속
as well
5m
as the velocity and
이렇게 올라가고
altitude of the
있죠.
vehicle. Our next objective is max Q.
네, 이제 맥스 Q에 조금 있으면 이제 도달하겠습니다. 오, 드디어 올라갑니다. 다시 말씀드리면은 발사한 지 8분 40초 만에 페이도를 배포하고 끝냅니다. 굉장히 빨리거리인데요. 네, 지금 고도 4km. 메인랜드 크루프가 될 것 같은데요. 아니 맥스 Q. 올라가는군요. 야, 굉장히 빠른 속도로 올라가고 있습니다. 고도 12km. 저도 이 발사 보려고 굉장히 고생했는데. 자, 맥스 Q 컨펌 됐습니다. 맥스 Q 확인됐고요. 네, 확실하게 지금 발사가 네, 맥스 Q 확인됐습니다.
Should have passed through max Q.
네, 맥스 Q
All systems
확인됐고요.
on the vehicle are nominal. And we are tracking it downrange.
아마 카메라가 있지 않을까 생각이 드는데요.
We'll be looking for MECO or main engine cutoff
네, 메인랜드 컷오프까지
at
지금
T plus 2 minutes
진행되니까요.
and 50 seconds.
이 아스트라 같은 경우도 이제 신생 회사이기 때문에 스페이스X가 지금 화려하게 보여주는 건 솔직히 아직까지 무리고 일단 발사를 성공하는 게 이제 목적이 하겠죠. 네, 일단 맥스 Q 확인됐고요. 메인랜드 컷오프까지 되면은 이제 대체적으로 이제 올라갔다는 것을 이제 올라간 걸로 이제 생각해도 해도 될 것 같습니다. 고도 73km 들었고요. 네, 메인 엔진 컷오프 확인됐습니다.
Copy.
네, 메인 엔진 컷오프 즉 미코 확인됐습니다.
That call out of the option means that the system will safely be able to ignite the upper stage after power stage
그러는군요.
separation. And that was MECO or main engine cutoff.
네, 안 보이죠 이제.
That was fairing separation and stage separation.
네,
You can see that the upper stage
네,
ether
분리가
element has
됐습니다. 근데 제가 또 이게 또 가부가 걸렸습니다. 아, 잠시만요. 다시 껐다 켜야겠네. 어쩔 수 없습니다, 제가. 다시 빨리 보여드리겠습니다. 아, 이게 계속 가부 걸리네요. 지금 지금 발사하고 나서 지금 다시 켰더니 발사하고 나서 다시 그 발사장 지금 현장을 지금 보여주고 있죠. 어쨌든 지금 메인 엔진 컷오프까지 지금 됐고요. 예, 배포까지는 뭐 8분 40초니까 거의 뭐 3분 안에 네, 거의 뭐 걸릴 것 같습니다. 아, 아주 환경이 엉망이라서 죄송합니다. 정신이 안 없어요. 정말로 죄송하고요. 하여튼 빨리 지금 업그레이드를 해가지고 더 원활하게 좀 방송을 하도록 노력하겠습니다. 어쨌든 지금 메이든지 컷오프까지 잘 이루어졌고 잘 올라갔어요. 근데 여기 환경상 어쩔 수 없이 그런데 상단 텀블링이 걸렸다. 지금 그게 지금 올라와 있어요. 다시 좀 확인해 볼 건데요. 지금 아마 2단 엔진이 텀블링이 지금 걸려가지고 2단계가 지금 밀렸다. 지금 환경이 지금 상황이 그렇게 좋지만은 않은 것 같습니다. 네. 지금 또 올라가는데 피드가 중단됐어요. 지금 피드가 중단돼가지고 지금 2단 엔진이 지금 계속적으로 단계가 지금 급락하고 있다. 지금 그렇게 지금 올라와 있습니다. 네, 지금 그래서 형이 아마 최종 발사가 실패한 건가요? 좀 하기 필요합니다. 네, 지금 그러니까 지금 1단하고 2단 분리 과정에서 이상 현상이 지금 발견됐고 2단이 지금 네, 페어링도 지금 재료도 지금 배포가 안 돼 있다 지금 나오고 있고요. 그래서 페어링 내부에서 네, 페어링이 분리가 안 된 걸로 지금 분리되지 않고 2단 전원이 뚫린 것 같다 지금 뉴스가 나오고 있습니다. 첫 발사가 이렇게 쉽지가 않습니다. 지금 사진이 지금 상황이요. 이게 2단 분리가 될 때 엔진 점화에 텀블링 햄버지 회전이 있어가지고 2단 엔진이 점화가 안 된 걸로 지금 파악이 되고 있어요. 안 좋아요. 네, 안 좋습니다, 상황이. 솔직히 예상을 했어요. 이렇게, 샷발사가, 네, 2단에 문제 생겼다는 겁니다. 이미 지금 8분 26초 지나고 있잖아요. 40초 되면은, 실패를 한 것 같은 느낌이 드는데요. 거의 3분대 예, 점화가 안 된 걸로 지금 이게 페어링이 분리가 안 됐고 언제 그 제가 한번 그 영상을 한번 보여드릴까요? 걸려서 점화가 안 되었네.
Thanks for standing by. We're still waiting for more information on the LV 0008 mission.
발사가 실
Right now, you're seeing a view of our pad at Cape Canaveral, where the team is securing.
아마도 네 9분 지나가서 지금 발사는 성공했는데 네 2단 엔진이 점화가 안 되고 아니 예 아니 날라가 버렸어 날라가 버렸습니다. 그래서 그 영상을 한번 더 보여줄 건데요. 보실까요?
And that was MECO, or main engine cutoff.
네, 메일은 컬러프 될 때 걸렸어요. 걸려가지고 점화가 안 된 거예요 지금. 그래서 아예
That
이렇게
was fairing
분리가
separation and stage separation. And you can see that the upper stage
Ether
ether
is
engine
running.
has lit.
이게 아마 그 2단 밑에 게 분리가 안 돼 버리고 그 아예 2단이 점화돼 버려 가지고 아예 다 날라가 버린 것 같아요 그냥. 예 지금 상황은 그렇습니다. 첫 실패가 나온 것 같네요. 거의 이쯤 되면 뭐 네, 안타깝습니다. 이번에 성공했으면은 진짜 역사를 쓰는 건데요. 안타깝게도 이게 그리고 자 지금 아까 그 3시에 발사했던 그 아리안스페이스의 원웨이 위성 있잖아요. 14개의 원웨이 위성이 방출되었습니다. 그래서 네 번째 분리가 하게 됐는데 아직도 멀었습니다. 14개 지금 있으니까 20개 한 20개 더 남았죠. 20개. 아쉽습니다. 등간에 아이스는 예, 상당한 타격이네요.
And thank you for standing by with us. Unfortunately, we heard that an issue has been experienced during flight that prevented the delivery of our customer payloads to orbit today. We are deeply sorry to our customers, NASA, the University of Alabama,
예,
the University of
실패했습니다.
New Mexico,
나사한테
and the
굉장히
University of California,
미안하다고
Berkeley,
굉장히
more
미안하다 지금
information will
이야기를
be
하고
provided
있죠.
as we complete a data review. And you can follow along for updates on Twitter at Astra as well as on our website,
예,
astra.com.
오늘 발사는 여기서 끝내고요.
And
예,
everyone, thank you for tuning in for today's live coverage, and thank you to Astra for partnering
안타깝게도
with NASA Spaceflight and allowing us to broadcast this launch to everybody. And again, stay tuned for further updates from Astra and from NASA Spaceflight. But thank you all so much for watching, and stay tuned for more information. But we'll see you later. Thanks, everybody.
예, 실패한 걸로 봅니다.